5.3 Transformations of sine and cosine graphs. This shows you when there will be a vertical stretch or compression. So if a is greater than 1, then there will be a vertical stretch, and if a is between 0 and 1, there will be a vertical compression. The amplitude of both of the graphs will be a. This shows you when a horizontal compression or horizontal stretch will happen. So if k is greater than 1, then there will be a horizontal compression by a factor of 1 over k. And if k is between 0 and 1, there will be a horizontal stretch by a factor of 1 over k. And the period of both of the graphs will be 360 degrees divided by k. This tells you if you should move the graph to the left or to the right. So if d is positive, then the graph will be shifted that many degrees to the left. And if d is negative, then the graph will be shifted that many degrees to the right. This tells you if you should move the graph up or down. So if c is positive, then the graph will be moved up that many units. And if c is negative, then the graph will move down that many units. This is called a vertical stretch. As you see, the black graph is the original sine graph. But because there's a 3 put in front of it, we're going to multiply all the y values by 3. So 0 times 3 equals 0, 1 times 3 equals 3, 0 times 3 equals 0, negative 1 times 3 equals negative 3, and 0 times 3 equals 0. As you see, this graph has been stretched. Now this is called a vertical compression. As you see, the black graph is the original sine graph, but because there's a 0.5 in front of it, we're going to multiply all the y values by 0.5. So 0 times 0.5 is 0, 1 times 0.5 is 0.5, 0 times 0.5 is 0, negative 1 times 0.5 is negative 0.5, and 0 times 0.5 equals 0. As you see, the graph has been compressed. This is called a horizontal stretch. As you see, the black graph is the original sine graph, but because there is a 0.5 put in front of the x, we're going to multiply all the x values by 2. Imagine the 0.5 as a fraction. It would be 1 over 2. We're going to flip the fraction so it will become 2. That is why we multiply the x value by 2 and not 0.5. It's always the opposite of what you think it's supposed to be. So 90 degrees will become 180 degrees, 180 degrees becomes 360 degrees, and so on. This is called a horizontal compression. As you see, the black graph is the original sine graph, but because there is a 2 put in front of the x, we're going to multiply all the x values by 0.5. Imagine the 2 as a fraction. It would be 2 over 1. We're going to flip the fraction so it will become 1 over 2. That is why we multiply the x values by 1 over 2 and not 2. As I said before, it's the opposite of what you think it's supposed to be. So 90 degrees will become 45 degrees, 180 degrees will become 90 degrees, and so forth. This is called translating the graph certain degrees. As you see, the black graph is the original sine graph, but because we have x plus 90 degrees, we're going to move the sine graph 90 degrees to the left. So move all the x values 90 degrees to the left. But in this graph, it's the opposite, because we have x minus 90 degrees. We're going to move the graph to the right 90 degrees. So move all the x values to the right 90 degrees. Here we're moving the graph 2 units up because we have y equals sine x plus 2. So we move all the values 2 units up. Here we're moving the graph 3 units down because we have y equals sine x minus 3. So we move all the values 3 units down. When we have a negative in front of the sine x, that means that there is a reflection in the x-axis. So we multiply all the y values by a negative. When we have y equals sine minus x, that means that there is a reflection in the y-axis. So we multiply all the x values by a negative, but keep the y values the same. So let's see some examples. We have y equals 2 sine x plus 45 degrees minus 1. So in black, it's the original sine graph, and in pink, it's the y equals 2 sine x plus 45 degrees minus 1. As you see, there will be a vertical stretch by a factor of 2. You're going to move the graph to the left 45 degrees because it's a positive and it's always the opposite. And we're going to move the graph 1 unit down because it's a negative. So the red graph has been stretched by a factor of 2. The blue graph has been moved 45 degrees to the left, and the pink graph has been moved 1 unit down. Here we have y equals cos x plus 30 degrees. As you see in the black, it's the original cosine graph, and in the blue, the graph has been moved 30 degrees to the left. Here we have y equals negative sine x plus 90 degrees plus 3. As you see, the black graph is the first graph. The orange graph has been stretched by a factor of negative 5. Because there's a negative in front of the sign, there is a reflection in the x-axis. The second graph is the purple graph, which has been moved 90 degrees to the left. And the last green one, it has been moved up 3 units. This is the last example. We have y equals 3 cos x plus 2. The black graph is the original sine graph. The purple has been stretched by a factor of 3, and the green graph has been moved up 2 units. Always remember, we always do translations last.